Hi everyone, my name is Doris Amoakohene, and I'm excited to share my research with you all with benchmarking performance for the Data.Table package. I've been working on this project for a year now, as of my graduate research at the Northern Arizona University, and I'm working on this with Toby Hawking and my co-worker Aniba. And the outline of my presentation is from the introduction. We visualize the time result, for performance regression, the GitHub action, and then the conclusion. As part of benchmarking the performance of the Data.Table package, we do two things. We do the comparative benchmarking, and then we do performance testing. Comparative benchmarking is comparing the Data.Table package to other packages in R and other packages in other languages like Python that performs a similar task. So we have Data.Table versus Pandas. So that is a different library in Pandas that perform the same task as Data.Table, and Data.Table versus other R packages. And then we'll look into that later in the slides. We also have the performance testing, where we evaluate the performance of the different versions of the Data.Table package by benchmarking their memory and time usage. So say benchmarking packages. So for benchmarking packages, we have packages like airspeed velocity, code benchmark, Tombstone, and Python's benchmark that usually rely on a single data size for benchmarking. And as part of our research, we utilize the atime package, which was developed by Toby, and it allows us to use a sequence of n values to generate and also generate a visual plot. The atime package, as I said earlier, is a package in R designed for asymptotic timings, enabling the comparisons of time and memory usage across various R codes. And then it helps us to input a sequence of data size, which is denoted by an N. And we also have a GitHub action implemented in there, which was developed by Annie, my co-worker. So we continue with visualizing the time results of different or various functions with Data.Table. So there are different functions in Data.Table in R. Sorry, there are different functions in R that performs the same tasks as Data.Table. So we usually do a comparative benchmarking to compare these packages with Data.Table to see how Data.Table is doing. So to do this, we utilize the atime from the time package, so the time function from the time package, and we set our n, which is the data size, to vary over, and then our set of expressions to evaluate for every data size before timings. Then we have the functions or the name list of expressions to time. Yes, so here you can specify any number of functions or expressions you want to time. So with this, to know which one is fast and which one is slow, usually the one which is fast is geared towards the left, and the one which is slow is geared towards the right. So we could see that this is a simple function, no named function that we're going to time. And we could see that the fastest way going way towards the left as to the slow. And we usually have our n on the x-axis, that's the data size to vary, and then our computational time in seconds. And as we time, we give it a number of seconds to time over. So when that seconds or the number of seconds is reached, it cuts, and then you could see the number of n or the number of data size that was read, read or whatever it is that you were doing. For example, the first example that we talk about is writing series of CSV files with the Data.Table package, and then the Pandas, which also has a function to CSV, and the Data.Table has a F-write. So we are writing CSV files with Data.Table and then with Pandas. And then as I said earlier, we have the n, the number of columns to write on the x-axis, our median time or computational seconds on the right, on the y-axis. And then this one we set the time to 10 seconds. So within the 10 seconds, you could see that Data.Table was able to write a lot of CSV files than the Pandas. And here we are benchmarking the data table again, Afriyie, against other R packages that also write CSV files. And then here we used the poleax in R, the write CSV in arrow, the read R, write CSV in read R, and then the data table Afriyie again. And here we also see that the data table Afriyie wrote as many columns than these other packages. Our third example will be the data table reshaping, or using data table to reshape from wide to long. So we have the reshaping from long to wide and then from wide to long. And here we are utilizing the data table melt to reshape data from wide to long. And then we are comparing it to other packages like start reshape, reshape to, and the tidy our pivot longer. And then here we could see that the data table is not always the fastest, which is why we use this benchmarking to identify optimization opportunities and improve the performance of the package. So this is one of the reasons why we are doing this benchmark, to see which place the particular package is not improving, and then try to improve the performance. All right, so we move on to performance testing. So the performance testing, we use the atime versions from the atime package. And then the atime versions allows you to specify some number of versions that you want to compare from the same package. So we have the atime versions, atime function for performance testing over different versions of an R package. And usually we have the package path. So you get clone package that you want to perform, use it and do the performance testing on, and you specify the path to where you get clone that particular package. And you set your N again here, and the package edit function is automatic, which helps you to edit the package before installation here. And then you have your expression, and then the expression that you want to time over, or you want to perform the performance testing on, and you have the various versions of that package that you want to compare. Okay, so we compared this, or we did, was this usually a GitHub issue that was reported on the data table page, and it was the set DT extremely slow for wide inputs, which is an issue number 5426. But the PR that fixes that issue or that regression is the PR 5427. So here, simply put, those two versions that we are trying to compare, the slow is where the regression happened, or the version that was reported, or the issue was reported on, and then we have the fast where the issue was fixed, so a new version was released. So we say that that's one, two. We have our N, the data size on the x-axis, and our computational time in seconds on the y-axis. And we could see this, that indeed the issue was fixed. As we can see, that the new version release was the fastest, and then the regression was the slowest. Usually we do a performance testing where we compare 3 different versions. So there was a before the issue was brought up, where the issue was, and then the fix. So if you say before means that where was the issue, what version was there before the new version was released to bring up this issue, the regression, and then which version was released to fix the issue. So we have these 3, the regression, which was where the issue was reported, and we have the before the issue was reported and the version that was released to fix the issue. So if something was fast before, we expect that it should be fast as the fixed. You get it? Yeah. So we have usually the before and the fixed should move not very cool, but almost the same, because we expect that before anything was reported as being slow, it was actually fast before it became slow, then it gets to be fast again. And at the same here, we have the N on our x-axis and then the computational seconds on our y-axis. Lastly, we'll talk about our GitHub action. So the GitHub action, as we all know, is an automated workflow that can be set up in the GitHub repository to perform various tasks such as building, testing, deploying softwares. So it helps identify and address performance issues, ensuring that the package is performing well. And for our atime package, we have this GitHub action, which has been implemented in there. And usually, the unique feature about it, I usually comment the generated results on the pull request to help identify potential performance regressions introduced from incoming changes. So usually this is how the GitHub action or whatever, if you put up the action, this is how usually will show on the particular pull request. So you have the crown, the base, and then the head, and then the two versions that you are trying to look at. So usually the head and the new version release or the fixed version, that is the fast also. The fixed version is usually called the fast version. Yeah. So you can see that the head is usually equal to the fast, and then we have the base, and then the slow, and then the crown. So with that, you still use your atime versions. You can use the atime once you run it locally. You can use the atime versions where you specify all these versions: the head, the base, the crown, and then the other whatever versions you are trying to compare. And now so it comes up with your n being on your x-axis and then your computational time in seconds on your y-axis. So we conclude that the data table is an efficient package for data manipulation, and data package proved to be exceptionally useful for conducting comparative benchmarking and performance testing. Thank you.